Let's do this. We are live. I'm a few minutes early. I thought I might just pop in a few minutes early to check all my tech specs. I mean, so far so good. So far, all I'm getting is a warning about my video resolution, but to be honest, that's not surprising because the camera on my drawing tablet looks like someone smeared Vaseline on it for like an old-timey movie effect. I'm not really sure what the deal is with that. All right, we've got a few minutes to go. A couple minutes to go before we're officially live. But if anybody pops in, I'll be sure to say hello. I'm also kind of just monitoring the latency. I think I've got audio. Looks like maybe I don't. Let me see here. Oh, I do. Okay, great. I don't want to get like a weird audio echo, so I'm monitoring this on another screen, but I want to keep the sound off. Okay, and I'm just talking a little bit to get myself comfortable as well. Hope you don't mind. Yeah. We're a couple minutes to go here. It looks like there's 6 people or so in the chat, so if you're there, feel free to pop into the chat and say hello. Maybe tell us where you are, or what time it is anyway, if you don't want to disclose your location. I don't know. Yeah, I'm in New Jersey. It's 9 p.m. here. The kids are in bed. I'm in my secret lab in the basement. And I'm excited. I'm excited to try this out, to try live streaming a lesson on color theory. You know, this is a new format for me. My attention span is really suited to the TikToks that are like 45 seconds long. I tend to do the best with those, but we're going to be here for, I'm guessing, 45 minutes, maybe a little longer, depending on how Q&A goes. So that's scaling it up quite a bit. And I'm excited. I'm excited to interact and to just kind of test the viability of this. You know, I am a teacher by trade, but I've never attempted teaching exactly what I'm going to try teaching tonight. Hello there, Chris Moran. Thanks for popping in. I think I've got about 6 people in the chat. I might wait a couple more minutes before I kind of launch into the lesson here, which of course, you know, if we're thinking ahead to the replay of this, the first few minutes of this are probably going to be very boring, of just me nattering on and kind of testing the waters and all that. So maybe I'll put like chapters if I can figure out how, so anybody watching the replay can skip to where this thing actually gets rolling. Clara is here. Welcome. In a bus from the Netherlands to Denmark at 3 a.m. Well, that's kind of a cool situation to just picture. I've been on nighttime buses before, and there's kind of they've got their own vibe, don't they? And we've got Rob Wiley. Welcome. Thanks so much for popping in. Awesome. It's just awesome that people are here. I appreciate it so much. And we've got Chris in Brooklyn, but you're from New Jersey, so that's cool. You know, if you've seen my TikTok channel here and there, I kind of throw a little Jersey pride in there, so always happy to meet somebody from my home state online. Very cool. So we've got a few folks in here. I think I'll start just introducing what I plan to do here. And hopefully, you know, as people start trickling in, we'll get the ball rolling. My aim is that you'll have something valuable you can take away from this session. So welcome to my class on choosing colors. I want to start by saying I'm honored that you've entrusted me with an hour or so of your time. And it's just such a pleasure to have you here. So here's our aim. Here's what we're going to try to do. You are going to leave this with more confidence because you'll have more tools at your disposal to choose color combinations that you feel good about. In other words, you'll have some tools for constructing harmonious color schemes. Whether you're a painter, a digital artist, whether you're just choosing your outfit for the day, you're designing a UX for an app. There are a lot of tools out there, and there's a lot of conflicting advice and conflicting theories. My goal is really just to give you a few ideas that you can put into action, but also give you a stronger foundation for how to navigate the color space. Rob says he's sometimes Philly, sometimes New Jersey. That's pretty cool. I mean, Philly's a great city. Good stuff. So there's going to be 3 sections to this lesson, and I'm going to have a timer on to try to keep tabs on it, but I also want to allow for Q&A between, sections 1, well, let's say between sections 1 and 2 and between sections 2 and 3, and then we'll save a little time at the end for Q&A if you're going to hang out a bit longer. And I'm going to invite you to do 2 things to get the most out of this lesson. Number 1, I invite you to follow along with the pencil and paper, if you can. If you're on a bus and it's 3 a.m., maybe not, but you can always come back and watch the recording, because I'll post this on YouTube afterwards. But if you can follow along with a pencil and paper, I think it'll help you get more out of it. And secondly, I invite you to screen grab. Just do a screen grab if there's a graphic or a sketch or a doodle that makes something click for you. Do a screenshot. I really invite you to do that. I've learned a lot by kind of collecting screen grabs from different webinars and Zoom sessions and things, and so I always encourage people to do that. Okay? So again, I'm going to post this afterwards, so you can always go back and review if there are valuable things for you that you felt like, oh man, what was that again? You can always come back and watch. Alrighty, we've got Bryce Brown, hello and welcome, and Rudy Tootie. I recognize a couple of these names. You guys have been awesome. We've interacted before, so thanks so much for taking the time to be a part of this pilot, to be a part of this first attempt at teaching color theory online. So we're going to jump into our first section here of the course, or the class, let's say. And I'm working in Clip Studio Paint. Let me just make sure I have my windows arranged the way I want. You should see my color picker tool in the upper right, and I'm up here in the upper left. I apologize if as I draw and sketch, my arm covers the camera. I don't know why they put it here. I guess they don't like left-handed people. This thing can flip, but then the buttons are on the wrong side. It's like, oh, what are you going to do? So anyway, I apologize if my hand is covering the camera and I don't notice. So here we go. So what we want to do first is give you a primer on the color space, on the scientific color space. Kira Cooner says, woohoo, excited to catch you live. And hello from PA. So you're not far from me. I'm in New Jersey. That's great. Thanks for dropping in. Awesome. All right, so if you got a pencil and paper, the first thing we're going to do is we're going to draw a circle with a crosshair. And this is where I start. Because this is the basic structure of the color space, okay? And again, if you have pencil and paper, follow along, draw this with me to really kind of own the scientific basis for perceived color relationships. That's what this can show us. So we've got this crosshair, these 2 axes, and these 2 lines are called the opponent axes of color. There's a third one, which we can't see right now, but if I were to imagine this circle laying flat on the table, that third axis is at 90 degrees. I drew that kind of sloppy. Let's see if I get that right down the middle. There. And that third axis is the axis of lightness or value. But we're going to focus more on the other 2. This one's called the A-axis, and this one's called the B-axis. That's why C-lab is C-lab. L is for lightness, A and B, L-A-B. And the A-axis is, think of it like a teeter-totter, a seesaw at the playground. If the stimulus of the light entering our eye is weighing more toward the stimulus of the long cone cells, this thing is like a teeter-totter that's gonna go this way. And so this right here, let me grab a color, is kind of, it's more actually magenta, but in color science they call it red. So if my color stimulus is turning that, is tilting that teeter-totter that way, I'm going toward red. If it's equal, if there's equal stimulus between, let's say this is the long cone cells, and over here would be the medium cone cells. Actually, let me switch color here. So the medium cone cell, if the stimulus is kind of equal, we end up right in the middle. So we get kind of no color either way in terms of red or green. Okay? And if the stimulus is leaning more this way, obviously we're going to see green. Okay, so this is what, like a lot of people get the idea or have heard about the different types of cone cells in the eye, but that's like step 1 for color processing. Step 2 is this opponency model, this idea that before we get a perception of color, there's this processing that happens. And it says, those two signals are actually going to get weighed against each other. Am I getting more from the long cone or more from the medium cone? Am I getting this one or that one? And that's what's going to, the amount of which is going to give me some shade of either really vivid red, some kind of medium dull red, total gray, or if I get, to the other side of the axis, it might be more like dull green, or if it's all the way over. So again, like think of it like a teeter-totter that's registering an amount of imbalance. The B-axis is the other color contrast that we perceive, and that's the contrast between yellow and what I like to call indigo. You could call it blue-violet or deep blue, and those again are kind of these messages from the brain. So if I am getting more signal from this combined input of L and M, right? So the way our eyeball is wired, we actually combine the signals from the long and medium cones to perceive yellow, and then our processor compares that. Are we getting more of that, or are we getting more of the opposite, the signal from the short cone? So that's kind of like, we have 3 cone cells, but we have 4 key colors here. We have 4 what are called psychological primary colors. This goes all the way back to Ewald Hering's opponent process theory in like the 1880s or 90s, but basically they've confirmed that the wiring at the back of the retina is doing this. Why is this important for choosing colors? I mean, I think it's important to know that first of all, these are the fundamental opposite pairs. So if you have a color wheel like this one, let me just switch to my other view here. If you have a color wheel like this one that you buy at the art store, it's going to show you yellow and violet or purple are opposites, and it's going to show you that like a scarlet red and like emerald green here are opposites. We'll get into this later, why this is an issue and why it is this way, but basically this isn't how the brain processes opposite color signals, right? So it's important to know that, so that if you're thinking about color harmonies and choosing colors that go together, that you can space your hues correctly, okay? So I think what we want to also take away from this way of plotting colors to the color space is that, the way we learn hue, I teach high school students, and you ask them, like, what's hue as opposed to just what's color, and they can almost never answer you because it's quite abstract. But I want to show you how thinking about it this way that I'm plotting out here can help you understand what hue actually is. So let's say we get a little bit of stimulus from the L cone. We get the teeter-totter going this way. More weight is on this side. But we also get some stimulus going this way. What's going to happen is you can treat this like an XY graph, like you're doing, high school math here. And we get a point that's like here. That point is actually going to be somewhat of a red stimulus and somewhat of a yellow stimulus, so it'll give us brown, right? And this is how, lab space and other models that maybe computer programmers, lighting designers use, but painters don't tend to think this way, which is why in recent internet history that's just been this thing, and it's come into my space a lot, where people say, brown doesn't exist as a color, it's just dark orange. What they're really referring to is this idea of talking about a color as having a certain quality called hue. And if you measure, instead of measuring this brown as an amount of magenta stimulus versus an amount of yellow stimulus, if instead you think of it as an angle from the center, so let me actually draw that center point as black. If you think of that brown as on this angle that's coming out of the center of the space, which is all colors are equal, so we get white, black, gray. We don't get any particular color. We get an achromatic stimulus at the center. A color's position in terms of its angle from that central point can be described as hue, because it's kind of its identity in terms of how much ratio of those two different opposing stimulations are happening. And it's just easier for us to think of it as an angle around a circle. So when people say that brown is just dark orange, what they really mean is that orange and brown share the same angle of hue, right? So if over here in my color pickle, my color picker, you see it says H30. The hue is 30 in RGB. It's just, that's the number they assigned it. So if we maintain that hue of 30, but then lower the saturation here, we get closer and closer to black, right? So all of those different colors, those shades of brown and that orange, are all identical in hue, but we perceive them as different colors. We don't think of them as belonging kind of to the same color. And so that's why this like brown is just dark orange thing is a thing that people can even debate. So anyway, so that's, I think, as good a way as any to define hue. Hue is the angle. Hue is the angle that we assign a color. So, if I'm changing the hue and getting more closer to, I guess I went too far there, right? I'm changing this quality of the color that has to do with, really, but we don't think of it this way. It has to do with just how far over am I going before I'm going up. But we don't perceive or live colors that way. We live them more like the hue angle. So that's why we have that concept. So that's hue. And the other two qualities that, if you're new to color theory, that you want to think about are basically what we demonstrated with this line here, which is how far from the center, right? So if hue is the angle of where am I around the circle, the answer to how far away from the center am I is this idea of chroma, which basically means how pure or how far from gray, black, or white am I. Chroma is the best term to use for a pigment or something that reflects light, whereas saturation is the word you're going to see in a computer. They mean similar things, not quite the same thing, but they mean similar things, and they're just measures of how pure is the color or how vivid is the color. Okay, and then the third thing, of course, is lightness, which is how white or how black, right? So this edge of my color picker is a lightness scale. Okay, so hue, saturation, lightness. All right, so one last thing, if we're just talking about how do I navigate this color space, the last thing to I would say actually memorize, to like kind of log away, especially if you're an artist working in traditional media, is what are the paints or what are the pigments that I can use as touchstones for these positions. So let's go back to yellow here. The touchstone pigment for yellow, for like this, the closest to that line, is PY97. PY97 is a Hansa yellow. It's not Hansa yellow light. That's PY3. So it's a little cooler than cadmium, and it might even to some people appear slightly green. So that's a good touchstone pigment for there. The best one for this is phthalo green. Phthalo green plus white will give you something that looks somewhat like that, though not as intense, but it's spot on for the hue. So PG7, that's phthalo green blue shade, is a really good touchstone for that line. Then continuing around, we don't really have like a vivid blue pigment. Ultramarine blue is like somewhere over here. But we have a pigment that's right on that line, but it's just very dull. So it's like actually somewhere around here. So if I were to draw that with a swatch, it might look something like this, right? The hue angle should actually be 240. It's not quite, RGB space doesn't quite neatly map to these CIE spaces, but that's like a whole nother topic. But anyway, it would be something like this. And that pigment is PB60. Which is a pigment I found not a lot of people work with. It's called Indian Throne Blue, and it's this dark violet blue. It's a blue that leans violet. It's actually quite a nice pigment. It's just not super chromatic. It's not super intense, so I think a lot of people just say, like, what's the point? Anyway, the last one, the last touchstone pigment is, in fact, quinacridone magenta, PR122. And this magenta is not quite the same as RGB magenta. RGB magenta is actually somewhere around here. Let me show you the vivid fuchsia swatch. I think a lot of people actually call that fuchsia, especially in Europe. But in America, that's in computer, RGB, that's called magenta. And this is a cause of a lot of confusion because these two hues are quite different. But the name situation confuses. Right, it's like they're both magenta, but they're not the same color. So anyway, PR122, the pigment magenta, sits right there. So anyway, if you are ever in a situation, especially again, this comment goes especially to traditional artists working with pigment in any form. Those are your touchstones, right? If you ever want to kind of just quick and dirty sketch out a color space and try to like notate some harmonies, this is how to do it. You say, okay, it's PG7 versus PR122, phthalo green versus magenta, and it's PY97, Hansa yellow, cool leaning yellow versus PB60. And if you don't have PB60, ultramarine blue is close enough. Ultramarine blue is kind of just a little to the side here. Okay. So here's two kind of like advanced things. If you're like, okay, that's all great, I knew all that. Here's two more things for you to think about. I think it's something that trips people up as they get into color mixing and choosing colors. Number one, hues have different values at full purity. Different hues have full value. I'm sorry. Let me say that again. Different hues have full purity or full chroma at different values. So we're going to take this and again turn it on its side. So this wheel, so we'll put our kind of touchstone four colors on it again. We'll put them opposite each other here. You notice maybe you notice this, that my green and magenta are switched from the color picker. I prefer to put the red on the right side rather than on the left side because that's the convention in CIE color spaces. Anyway, we're laying it flat, and then we're going to imagine our lightness axis here. So this is actually wrong. This is not technically correct, right? Because yellow is such a brighter color, and indigo and violet at their fullest saturation are such darker colors that in fact it's more accurate to draw this something like this. So here's our lightness axis. Yellow is like up here. Whoops, let me grab yellow. Yellow's up here. Let's do like the main 6 primaries, CMY and RGB. Red is like, well, let me draw this shape here. It's kind of like, it's this weird shape. So red is a little bit lower at its fullest intensity. And then next would be magenta, which is a little bit higher. And then it goes to like indigo, which is lower. And it's really kind of like maybe a little more violet, right? It's the shortest wavelength we can see is down here because it's pretty dark. Because we don't see it that well. Our eye filters out UV, so we lose a lot of the violet wavelengths. And then as it keeps going, you get a lighter color, so that would be cyan. And then you get a darker color, green. and then white is up here and black is down here, right? So it's not really a flat disk, the color wheel or the color disk, if you're navigating that space. Is that important? I mean, it becomes important when you're trying to manage value and color at the same time. So you might say, okay, well, I might need to darken my really pure yellow, or I might need to add white to my blue to make it feel like it's the right value or something like that. So anyway, that's one thing to keep in mind if you're thinking at it on a more advanced level. And then the other thing is that actually objective hue angle. So this angle we're talking about here, right? If this is, orange, whoops, that's brown. If this is orange, that objective hue angle can actually be very different from perceived hue angle for desaturated colors. And here's a couple examples of what I mean. So if I take like a color that's a very magenta-y color, so I'm going to actually go a little below here, right? We see that as like a hot pink. It might even, some people even might see it as a cool red. But as soon as I start to darken it, even at full intensity, look what happens. It's on the same line here. That starts to feel more like a violet. Okay, so we're experiencing it more like it's over here, even though it's literally, objectively the same hue angle. The same things happens over in the greens. So if I have a minty green, it's leaning towards cyan, which might be somewhere around here. Right, we'd say, okay, that's a cooler green. But as soon as I darken it, even at full intensity, if I just put it down here, that feels like a greener green, right? So the point, again, is that knowing something's hue, especially if you're a digital person, you say, oh, that's hue 150 or that's hue 30. Knowing that hue objectively is not the same thing as knowing how somebody's going to perceive it. And so you've got to think in terms of that as this darkens, it might curve. As this darkens, it might curve. And then there's things like the Abney effect. Like if you lighten ultramarine blue, it actually starts to look more purple. So these weird things happen. And the bottom line is that hue angle, objectively speaking, that can be measured, is not always the same thing as what we perceive it to be. And I think these are some good examples of that. All right, so a couple of comments in the chat here. Yassine Brown says, hello, love your work. Thank you so much for being here. And then Rudy Tootie says, is it a Pringle shape? I think called hyperbolic paraboloid. So you're referring to this thingy here. Strictly speaking, not exactly. So it's, if I turn this flat again, it's kind of Pringly, but it's not just that from the side. It's actually three, because red, green, and blue, which are something like that, are the down points. So let's say these are all minus. And then yellow, magenta, and cyan are the up points. So it's actually got three. So it's 1, 2. I can't draw it. I can't even wrap my head around it. I tried to make one out of paper. But hopefully you get the idea that it's bending up, down, up, down, up, down. So it's like a trifold Pringle. I don't know. All right. So that is kind of the color space base. That's like section 1. We're kind of at the end here. In the next section, in a few minutes, I'm hoping to show you that as an artist or a designer seeking to choose colors with more confidence, you're probably better off abandoning altogether the traditional ideas about primary colors and the idea that complementary colors should mix to gray. That idea, complementary colors should mix to gray, is just so fraught with error. So we'll talk a little bit about that, and we'll talk about how abandoning those two ideas impact traditional color harmonies that you might be aware of, like triadic or tetradic or complementary color schemes. Those all get impacted by this. Okay, so before we get into section 2, let's do a little bit of Q&A. I'll check the comments here. I know there's going to be a little latency. There's going to be a little lag, so we'll just bear with it. Quaugera says, I'd never actually been taught the scientific complexities of color like this, and I went to art university. That's it strikes me to the core, but I'm not surprised. I went to a seminar online, like a webinar or whatever you call those things. Um, that was actually hosted by the Australian chapter of the International Color Society, or the ISCC, the International, whatever, the color people, the International Color Gang. Awesome, awesome, very educational thing that I was very pleased to be invited to. And there was a lot of talk amongst that group of highly educated and research based people about like why is it still taught wrong, like at the university level. And one thing that one guy said was David Briggs said this, the thing is, the people who were raised, the art professors who are like the head of the pyramid now at art schools, were the people that were raised in the midst of Johannes Itten's influence on color theory. So Itten's books that came out in the 60s and 70s, The Art of Color and The Elements of Color, like that's what they cut their teeth on, and now they're in charge. So they're not at the end of their career going to go back and question everything they knew. And like, they're just, it's like you can't teach an old dog new tricks kind of thing. So I think that's a lot of the reason that you can go to an art university and never learn all this stuff, because paradigm shifts take time, and I think we're in this 200-year paradigm shift when it comes to color science. What other questions can we address? We've just been talking about kind of how is the color space constructed based on human perception of how our visual apparatus works. I know I kind of covered a lot and didn't go in as much depth as I could have, because I want to move on to talk about color harmonies and choosing colors. But if you have some pressing questions, put them in the chat and let's talk about them. Crowgara says, would it be too much trouble for you to recommend 3 or 4 books to study color from 0 to pro? Hopefully books that aren't too hard to find. So a great entry-level book, especially if you're an artist, for like correct color theory would be James Gurney's book, Color and Light. You can get it on Amazon. It's actually one of the books that started my journey into this space. He talks about the basics of kind of why traditional approaches to color theory are limited and incorrect, and covers all kinds of lighting effects. It's great. It's a great intro book. Another couple books I could that are kind of more advanced that you might find useful. I've just been reading Harald Köper, German guy from the 70s, The Basic Law of Color Theory. He's a little quirky, and he writes for educators, so like the book is full of like exercises and demonstrations you can do to learn about color principles. So that's like a little bit more advanced. I think that's like a good university level maybe. And then even more advanced, I'm also reading a book called Color for the Sciences by a guy in the Netherlands. What's his name? Kendrink. J. Kendrink. It's an amazing book. It's super sciencey. There's a bunch of math in there that's above my level, but he talks a lot about the structure of the color space in ways that I find really interesting and inspiring. So that's kind of like a graduate level book that I could recommend. Color for the Sciences by Jan Kendrink. Bryce Brown says, isn't full saturation green a slightly higher value than full saturation magenta? Probably yes. Yeah. So, I mean, depending on, of course, how you're defining full saturation green, like RGB is a little funky and warped. Full saturation green, in terms of what we can perceive, is actually a more vivid color than RGB can produce. So, I mean, it depends on the space, and I kind of don't know off the top of my head if, like, optimal green, which would be, like, the theoretically most vivid possible green, would have a higher value than optimal magenta. My gut says no, they'd probably be about equal, but I don't know that. So that's something for me to look up. All right, I think we'll move on to section 2. So, of course, if you have other questions, and you can leave them in the chat, I can try to look at them after section 2 is done. So section 2 is called the limitations of traditional color harmonies. So I'm going to switch back over to my Clip Studio Paint space here so I can doodle and sketch a bit. So you are, if you are here, probably aware of the traditional color harmonies, the ones they teach you in school. Excuse me, pardon me. Color harmonies that are combinations of colors chosen based on their intervals around the color wheel. So we're talking this old thing, right? Actually, let me switch my camera back so we can just look at this for 1 second. So this guy actually has at its center kind of this, what we're talking about here. So there's like a dual complement or tetrad that's shown as a rectangle. There's another one that's shown as a square. It's a little fainter. Then you've got the triangle showing a triadic scheme, a split complementary scheme, which is just a more narrow triangle, and then a complementary scheme which goes across, right? So these are the traditional color harmonies. But I want to introduce to you a way of thinking about them that allows us to go beyond. Okay, so we're going to talk about these color harmonies as just decisions about how many hues and how much hue contrast. So you're balancing these two things. So here's a little color wheel again. We'll put our little key colors here. Whoops, I keep doing that. Here we are. Again, pardon my arm. I know it's probably a little awkward to have my arm covering the camera. Oops, it goes on the other side. So if this is our like quick and dirty color space here, the traditional color harmonies are asking how many hues, and remember hue is what angle, so I'm really just thinking like how many of the colors around this circle am I choosing? Okay, how many hues and how much contrast? Okay, so if we just think of all of the traditional color harmonies as answers to those two linked questions, then we can do something interesting. I'm going to make a table, basically. Okay, and going up, the value going up is variety, so number of hues. How much variety of colors do I want? And going this way is how much contrast between the colors I'm choosing. How different are my colors? Okay. So let's go through all of our traditional color harmony. So if I choose a monochromatic scheme, say all I'm going to use is different shades of magenta. So I'll swatch out a few here. They might be tints, so I'm adding white. They might be shades, so I'm adding black, but they're all just variations of one hue. What I'm saying is I want basically no hue contrast, M for monochromatic, and basically no variety of hue, right? All of my contrast is coming from light and dark, and from saturation. And so this is why in monochromatic schemes, gray can actually take on an apparent complementary contrast, right? So if I have this magenta color scheme, and I'll just paint like a little funky abstract piece here, and I just have all these different areas of different lightness and darkness, and then I throw in some purely completely gray. Look how green it looks, right? In that context, because my eye is going, there's just no hue contrast, and your eye is trying to supply it, right? So monochromatic is answering the question by saying, no hue contrast, no hue variety. All right. So the next color scheme would be analogous. So if I'm doing an analogous scheme, traditionally I'm defining that as a bunch of hues that are kind of next to each other on the wheel. So I might choose yellow, I might choose amber, orange, and vermilion, right? So what am I saying now? I'm saying I want more variety in my hues. So I'm going to put analogous up here. Because there's not a ton of contrast, right? And that's the point, is that all these hues are next to each other. Face cam went full screen. Drawing is invisible. We can see it. I'm guessing. Let me just check my. Aha. I'm so sorry. I'm glad you popped into the chat to say that. Well, I guess I ought to back up a little bit. I apologize. I see you're all shouting at me like, no, we can't see it. I'm so sorry. I thought I had switched back, but I guess I didn't. So anyway, to catch up to what I was demonstrating here. So how many hues, how much contrast, right? So monochromatic color scheme is this guy. It's only one hue, and any contrast I'm getting is from light and dark or from chroma. And then I demonstrated, like, if you have zero chroma, if you have gray within the context of a magenta painting, it will appear green or slightly greenish because your eye is begging for contrast of hue, but there is none, right? So monochromatic is answering this question: how many hues? Just one, so no variety. How much contrast? None. It's just one hue. An analogous color scheme, like this one, is saying, well, I want some variety. I have here 4 colors to choose from. I could even have 5 or 6 colors to choose from, but they're all next to each other, and so I don't have a ton of contrast to work with, right? Okay. Next we would, I guess, maybe talk about complementary. This guy's getting messy, so let me start a new one. So over here, let me shrink my my ink. Shrink my ink. Let's say we're going to do a lime green. Oh boy. Here we go. Lime green versus something of the violet persuasion. Okay. So we've got complementary colors. Now, if I'm just using a traditional wheel, it might say, okay, you got tints and tones and shades of those two. So I might say, okay, I've got like, I could do like a duller violet. I could do a darker violet. I could do a lighter violet. And then in terms of my springy green, right? I could say I've got some tints and tones and shades there. So how much contrast do I have? I have the most possible contrast because I'm choosing them for that purpose. I'm saying these are colors across from each other. So I'm over here in terms of contrast, but how much variety do I have? I only have 2 hues. So we'll put this guy about here, okay? What about a triadic scheme? A triad scheme is saying, well, we're going to have 3 colors, so it's going to land somewhere around here in terms of variety. And how much contrast? Well, they have the most contrast that 3 colors can have because I'm spacing them equally, right? So I have a good amount of contrast, but not, of course, as much as I would if I had 2 diametrically opposed colors. So I'm kind of somewhere in the middle, I guess, right, with the triad. So I'll just draw a triangle for a triad scheme. And then a tetrad scheme is kind of splitting the difference a little further, saying, well, now I have 4 colors, more variety, but as a result, I have a little less contrast, right? The only thing that remains is split complementary, and that's kind of in the same ballpark here because what's happening is you are just trading off. You're saying more contrast from this guy, but less contrast from each other. So you're not gaining or losing overall contrast. So what you can see is you kind of have all of this space that we haven't explored, right? These are all other possible things that we could do with color combinations that our traditional color harmonies have not charted. It's uncharted territory. So number 1, I invite you to chart it. Now that you can look at these color harmonies in this sense of answering these 2 questions, you can now find other answers to those questions instead of just those 5 or 6. All right, so much for traditional color harmonies. Good. And again, so sorry for my flub on the camera there. Okay, so the idea of these traditional harmonies, it's sound, right? We want to think about contrast and how many hues we're choosing, because that's how you structure the color of a piece of art or a UX design or whatever. Um, and it's a sound idea to make intentional decisions about how many hues and how much hue contrast. But when we're doing that, the problem is we can't rely on a traditional color wheel, right? We have to overcome the problem that the red, yellow, blue wheel, the traditional artist's wheel, is not going to give us correct hue intervals and is not going to space hues correctly. So here's one compared to the other. So here's red, yellow, blue, and here's, we'll call it CIE, meaning the commission that came up with colorimetry in the 1930s and refined it over the next century, that we're kind of basing ours on, right? Based in scientific observation about human perception. So red, yellow, blue says, we've got yellow, and then we've got actually red 120 degrees rotated from there, right? But CIE says we've got yellow, and red, what we think of as red, is actually not even to that halfway mark, because that halfway mark is more of a quinacridone magenta. Okay, and then red, yellow, blue is saying blue, and it's defined in different ways. Some people are going to put that ultramarine blue there. Some people are going to put more of an azure blue there. But either way, it's going to be warped, because the research is saying, no, actually blue is over here. See how different these things are. So what red, yellow, blue is going to say is a complementary pair of yellow and violet is actually something more like this. And what red, yellow, blue is going to say is a triad like that is actually not. That's not even right. It's this, right? So as you can see, these traditional color harmonies that rely on geometry, that rely on drawing a square or a triangle or what have you, if the geometry of the space is wrong, the harmonies are wrong. And you're not actually going to get maximum contrast between yellow and violet visually. You get maximum contrast between yellow and this indigo blue visually. Okay, so that's the first problem we have to overcome if we're going to think beyond the traditional color harmonies. But there are two more problems to get past, and I'm already like coming to the end of what I said this would be maybe 45 minutes. I really started this about around 9:05. So we're at 40 minutes and we're just getting to the end of section 2. So that's good feedback for me in terms of timing out this kind of thing. So let me try to finish section 2 and then we'll see what we want to do from there. So all right, so we talked about the problem of the red, yellow, blue space messing up the geometry of color harmonies. The other problem is, of course, the fact that, this guy, the red, yellow, blue space, is the way it is because this is how pigments mix, right? And this is a problem more for painters and people using pigments than it would be for like a quilter or somebody putting together haute couture, right? If you're using fabrics or things that you're not actually mixing physically together, you don't have to worry about this. The irony, of course, is that people using fabric or quilting or whatever, people using those things were taught this. So I don't know, I'm getting into the weeds, but hopefully you know what I mean. Basically, let's say here's the other problem. This is the problem I want to talk about. Perceptual complements are not mixing complements, and that's why this thing is what it is and why it still exists. So perceptual complements like yellow and indigo. These are perceptual complements. If you stare at a patch of indigo and then look at a blank wall, you'll see yellow. That's how you know they're perceptual complements. But they're not mixing complements, which means if I have these two paints, what's going to happen? I'm not going to get gray if I mix them together. I'm not going to end up here because perceptual complements are not mixing complements. What's going to happen is I'm going to end up with a dull green, because the mixing path of these two pigments, say it's Hansa yellow and ultramarine blue, is going to curve because of the way the math works out between their spectral reflectance profiles. So you can, this is the problem. You get high school art teachers, even college art teachers, saying, we're going to do this color theory assignment. You're going to choose a pair of complementary colors, and you're going to do a limited palette painting. And it's going to teach you how mixing complements gives you all these colors and neutrals in the middle. And it's just completely flawed, right? So, instead if you say, well, here's yellow, and here's blue. And if you teach somebody that purple is the opposite of yellow, because in your experience what happens is you mix that yellow pigment and that purple pigment, and here's what happens. It does go through that neutral point, right? So that's why people think yellow and purple are opposites, because yellow and purple paints mix to gray. But even then, you're not going to get the palette you think you're going to get, right? Because what you're taught to expect is this. What you're taught to expect is, I'm going to mix yellow and purple, and it's going to go in a straight line, and I'm going to get all of these colors. Even in Johannes Itten's book, The Art of Color, he shows a scale where you get all these, like tints or shades of yellow going to gray, and then on the other side, shades of yellow, on the other side, shades of purple going to purple. This is what Itten's scale looks like. But anybody who's ever tried to paint should know that that scale is actually doing this, right? It's not moving straight through the color space. It's curving, and that has implications. It means that your so-called complementary color scheme isn't really, and the flip side problem, that if you are actually using complementary colors, you're not going to go in a straight line either, but end up with green. It just means this idea that because perceptual complements are not mixing complements, you can't make a complementary color scheme painting with only 2 paints, right? You need 3. You need a third one, say magenta over here, to actually pull this green towards center, right? And so you end up mixing all these different ratios to try and straighten out your curving mixing path if you're really trying to do a visually complementary color scheme. And that's a way more complicated assignment, and not something that any first-year college professor is going to assign their painting student. So the whole approach is just perpetuating this idea, which is just not true to the color space. Okay, so these are some of the problems inherent in, it's not just complementary schemes, right, but also triadic or tetradic schemes where the geometry is just wrong. And they're very persistent problems. All right, so I'm just going to pop into the chat here for a moment. Breakthrough Color says to say nothing of the fact that the old school wheel puts purple in between red and blue, as if those two hues actually mix to make purple. That's a great point, right? If you mix red and purple, like a spectral red and blue, red and blue, they're actually going to lose chroma, and you're going to get something very close to gray, right? So that's an excellent point to add to that. We're just finishing section 2, and writer says, more lessons. I'm happy to go on for a little while longer and get into, because I do want to get into some of these. Really, this is all prelude to try and demonstrate to you some concepts that you can use to choose colors with more confidence. So I'm way behind my schedule, and I understand if you need to leave. But if you can hang out, it's about maybe 19, 18 of you here. If you can stick it out, that's great. And even if I'm just talking to myself at the end, it's still going to be great practice for me and learning how to kind of do this more effectively. So I appreciate all of you so much. So what else? We've got Bryce is saying, Robert Wiley says, will we be able to rewatch this? Yes, I will have it post. I think it's set to do that automatically. It'll post to the YouTube channel afterwards. Bryce Brown says, when it comes to a monochromatic scheme, and since hues can be perceived differently at different values, do you make slight hue changes for different values to make a perception? Yes, absolutely. If you're trying to do something that would be perceived as monochromatic, you will need more than just the color black and white. You will need a neighboring color to correct the curve if you really want it to be strictly monochromatic, for sure. And that goes more for some pigments than others. Crowdgara says, color schemes can be quite complex. A triad, for example, gives us 3 groups or points, but how do we choose the number of colors or chromas? We'll get a little bit into that in the next section if I can get there, for sure. That's a great question. Are the rules about color mixing, says Jay Burns, are the rules about color mixing the same if you're glazing rather than mixing pigments? That's a wonderful question. So glazing, it gets interesting. Kerpers in his book actually distinguishes several different types of pigment mixing, and I don't have it all at my mental fingertips, but it's a different type of subtractive mixing. Glazing is more like what happens if you overlay color filters together. So if you glaze yellow and ultramarine, you will get a very dark, almost black-like color because it's more true to how subtractive mixing works. Whereas if you mix those two colors, you get something that Kerpers calls integrative mixing, but that most of us still call subtractive mixing, and it isn't quite accurately subtractive mixing. Great questions. Clara asks, what about CMY? Sorry, I don't quite have the context for that question. CMY is a great gamut because it's pretty wide. Maybe what you're kind of asking is this. Let me bump up my... what is going on with my pen size here? It's microscopic. Oh, I'm on the pencil tool by accident. There we go. So maybe you're asking this. Is it curvy, right? So if you have quinacridone magenta, you have a nice Hansa yellow, and then you have like maybe a phthalo blue as your primary. So that's somewhere around here. That's a pretty good gamut because those mixing paths curve outward rather than inward, right? If you mix red, which is up here, like cadmium red, with ultramarine blue, which is like here, those mixing paths curve inward because these colors are close to like only stimulating one type of cone cell, the long cone cell or the short cone cell. But cyan is stimulating the short and the medium, and magenta is stimulating the short and the long. So since both of those colors are stimulating more in our eye, when we mix them, we retain more chroma, which is why CMY is a better gamut than our RYB. So that's a good question. Kira asks, I'm fine hanging out, or says, I'm fine hanging out longer. That's what I'm here for. Cool. Appreciate it. Clara says, I'm stuck on the bus for like 4 hours, so you're hanging out as well. That's great. And Quackera says, I'd make you dinner just to listen to you talk about it. Well, I do accept payment in food, so that works for me. All right, well, if you're hanging out, let's move on to the next section. I appreciate, again, your willingness to kind of be my guinea pigs here. And again, I hope you can gain some value from this. So let's sum up the last section. For choosing colors, suffice it to say you should not choose complementary colors based on the belief that you can do a limited palette painting with them and derive the neutrals on your palette from those complementary colors. The same goes for triads. And so what do, right? Here's what we'll talk about. Scrolling down to my next section and skipping some things here. I want to give you more advanced tools to find pleasing color combinations and to kind of think more in terms of gamuts than just these abstract shapes, triangle, line, square, that the traditional color harmonies give us. So here's the thing. Color choices should support design. Okay, so I want to talk about choosing colors in this section as more a function of a design choice and as something related to proportion. Okay, so we're going to call this section choosing colors for proportion. Okay. I almost feel like the last section will make you less confident because you're like, well, if I can't choose two paints that are going to mix together to make a complementary scheme, what do? I would say don't worry about it. That's a flawed approach to begin with, and I think you're better off doing other things. So colors for proportion. Why is proportion important? That's how design works. You know, if you're laying out a web page, you're saying this is bigger because it's more important. This is smaller because it's a subheading. I'm going to leave more space to call more attention to my button, right? You're using proportion, how much versus something else, to signal things to your viewer. So proportion is kind of, to me, is one of the key things for graphic design as a principle. So color choices should support design, and design is about communicating with the viewer, and good design, no matter the medium, manages proportion to create hierarchy. I'm going to write that because I think it sounds pretty smart. Design, good design, manages proportion. So how much of A versus how much of B, right? Manages proportion. Good design manages proportion to create hierarchy. In other words, to create a sense that this is more important, this is of medium importance, and this is of less importance, right? To create hierarchy. And so color can do this. And not just in a web design, but in a painting. Anywhere where you're choosing colors. In an outfit, anything. So if we can do this, then here are some ways that proportion can guide your color choices. Okay. First, let's talk about proportion in hue contrast. So remember, if we scroll up here, I had this little table. We're saying, and I scribbled all over it, that the traditional color schemes are really just a function of how many hues, how much contrast, right? So let's think more proportionally, okay? Proportion in hue contrasts is one great way to approach choosing colors. Proportion in, I'm just going to write that once so I don't have to bore you by writing on a screen. And then we'll say hue contrasts is our first one. Hue contrast. So what does that mean? Our traditional color harmonies are all decisions about how many hues and how much contrast. If the contrasts are all the same, like in a triadic or tetradic scheme, there's no hierarchy. Okay, so here is no hierarchy. Sure, we've got a variety of hues. We've got three. Let's say we've got CMY, right? But they're all, let's say it should be cyan, should be somewhere over here. And magenta. Since they're all equally spaced, the amount of contrast between those three colors is the same. So none of them has a proportional advantage over the other. Okay? So there's no hierarchy. There's no sense that one of those three colors is the key color. So to create a hierarchy, here's an idea. All the colors should have different intervals between their hues. So let's visualize that. So this is not what we want necessarily. Let's do something else. Different intervals between hues. So let's say I know I definitely want to use yellow, but I'm going to divide this. And if you've ever studied Fletcher, the Fletcher palette control system, this might look familiar to you. I'm kind of riffing on that. So I've got 12. Rather than have them all be 1, 2, 3, 4 apart, let's make one of them 5 apart. So let's make this a deeper violet, something more like this. Okay, there's an interval of 5 here. Then let's make this one 1, 2, 3, 4. Okay, what's that? It's going to be like a phthalo green. Okay, and then that means my remaining interval is 3. I have different amounts of contrast between all three of the colors I've chosen. Okay, so Frank Morley Fletcher, in his system, his concept was sound. This was his idea basically. He said you could choose up to like 5 colors as long as the intervals between them are all different. You'll still have structure in your piece because the amount of difference between each color will be different. Because if you just take the classic approach and have a pentagon, right? If I'm just choosing 5 colors equally spaced, it's like I might as well just use every color of the rainbow. I can't derive any structure from that. I'm just like a kid using every paint in the box kind of thing. But if I instead make sure that all of my proportions are slightly different, and then like let's say there's one really close to this one, right? I can use 5 colors, but because I've grouped these, I'm suggesting that these two are related. They're analogous, right? These are basically complementary. These are like a split complement. I end up with all kinds of different color relationships within that structure that can communicate different things. So I end up with something that's much more design ready, much more ready to create hierarchy or differences in perceived importance or perceived role or whatever you're doing. Okay, so proportion in hue contrast is that one, is that idea. The problem, of course, with Fletcher, Frank Morley Fletcher, is that he was using a red, yellow, blue wheel. So when he was trying to actually wonkify it, he ended up straightening it out. So his like key palette that he suggests ends up just being a tetradic palette, which I find kind of ironic because he was trying to work his way out of that system, but he was still bound by it. All right, so proportion in hue contrast. So let's look at another one. Proportion in chroma contrasts. Okay, so what does that mean? Chroma contrasts. Contrasts in how much chroma or how much purity I'm choosing. Okay, so each color in your palette should have a different purity or chroma. What does this mean? Well, let's keep developing that palette that we had before. So it turned into something like yellow, violet. What kind of violet was it? It was a fuchsia-y violet. It was somewhere around here. And then my phthalo green, which was like here. Okay, so I've got these three, but they're all pretty intense. So I'm going to lower one a lot. So I'm going to go back to my yellow, and I'm gonna dull it down. I'm not maybe going to darken it. I'll just bring it toward the middle. All right, so now I've got this color. My green, I'm going to bring it down, but not as much. I'm going to put it in the middle. Okay, so it ends up here. And my like fuchsia purple here, I'm going to leave it all the way cranked up. Okay, let's just play with this a little bit. Here's my fuchsia. Let's say that's probably, I mean, obviously that's going to be the most eye-catching color. I'm going to eyedropper this guy and say, okay, I got it. It's on a blend mode where I'm getting some interesting intermediates too. And then I've got this. I feel like that's still too bright. There we go. It ends up, it's darker but more vivid than the yellow, right? So I end up with, let's just square it off so it looks more like a painting. Nice little abstraction here. I end up with something that feels a little more harmonious, I think, than it would if I were just using all of these at full tilt. And this is a really wacky example, but let's use kind of a more classic example. So before I talked about Fletcher, now I'm going to talk about Amy Sawyer, who's kind of a little-known artist, British artist from the early 20th century, late 19th, early 20th century, who developed her own color wheel. I did a video on her a couple weeks ago. And in her color wheel, one thing that she talked about in her patent application for her color wheel was how landscapes, harmonious landscapes, are actually rendered harmonious by the careful management of chroma. And so her thought was, well, maybe one of the discs on my color wheel can actually, here, let me do it this way. One of the discs on my color wheel can have a little hole toward the center. She had all her high chroma colors at the center, and then as they went to the edge, they went toward gray, so the opposite orientation of what we've been working with. And then so if you took out a whole window here, you'd get slightly analogous colors of medium chroma, and then if you opened a window here, you'd get that same palette but even lower chroma. So here's what it might look like. You get a patch of very vivid cyan blue here. You get medium chroma cyan blues, and then, you know, slightly greenish, and then we'll go the other way, slightly bluish. And then down at the bottom, very low chroma versions of those colors. And they might even be really light, right? And you could go to the green side, and you could go to the blue side. And she said, okay, here, this is the color you use for the sky in a landscape. These are the colors that you use in kind of the principal elements of the landscape. like on the ground. And then these are the colors that you might use for distant mountains and clouds and things like that. So she was really thinking, like, this is the other half of the equation, right? Like Fletcher is saying we can control our palette by making different choices of the amount of contrast between hues. And Amy Sawyer is saying we can make a harmonious palette by making different choices of the amount of chroma we're including. Why not use both these ideas? Play with these ideas. Proportion through hue contrasts, proportion through chroma contrasts. All right, let's look at one more. Spatial contrast. I mean, and this is kind of the obvious one, right? That you probably already know. That if you have a painting or a UI for a website or anything where you're kind of laying things out, let's just do a little mountain, and here's the moon, and I don't know, here's a cactus. There we go. Here's a cow skull. Boom. What I want to think about is how much space each color is taking up. So now we're talking about proportion in spatial contrast. And this one you can really have a lot of fun with. So each color in your scheme should occupy a different amount of space in the composition, right? So same thing with this. All the distances are different, right? So let's say if I want to do this landscape, I want to make sure the proportion of, let's choose some colors here. I'm just going to choose random colors, like disgustingly random colors. So here's like a vivid green. Here's a dull sappy green. Here's a salmony color. I'm literally just going random here. I don't know. That's awful. I hate it, which means it's perfect. There, a nice dull cyan. All right, so I could have the stupidest, randomest combination of colors, but theoretically, if I spatially contrast them, if I allow them all to occupy different amounts of space, it will still come off as harmonious, and you can get away with it, right? So let's say if I've got 5, right? Let's say if I've got 3, I'm kind of jumping around here. If I've got 3 colors, I might try something like 60, 30, 10%, right? If I have 4, I might, I don't know, let's say, I can't wrap my head around it. Let's do 5. Here, I'll just go back. So I can do this fast because I wrote these numbers down. I'm not good at math. So let's say it's 60, 27, 8, 4, 1. Okay? So I'm going to pick one of my 5 colors, and it's only going to occupy 1% of my painting. Let's take this hot green and just, we'll do it as a highlight on that cactus, right? So check. 4%. I don't know. How about this guy, right? So I can, that's obviously more than 1. I'll cover it. Don't worry. So maybe I just do little flecks of that color in the sand, right? Check. 8%. Okay, we'll do 8% of this purple color. I'll use it like an impressionist to shadow my saguaro. Okay, that's maybe roughly 8%. 27%. Now I'm getting close to like a quarter of the image. So let's use our gross cyan. And we will fill the sky with it, but we won't fill the whole sky because that would be more than 24%. Right? We'll leave some space around the moon, some moon glow. Okay, that's probably, I don't know, that's probably in the ballpark. And then what do we got left? We got our green color, which is going to now be 60%, right? And I just kind of went at this. I didn't really plan it out, but you can see the power of this if you actually do plan it out or kind of do some thumbnail sketches. You can say, that 1% doesn't have to be all in one place. It could be these tiny little hot green highlights everywhere, right? I could have a little bit here and there and there. This could go in the mountain, and I can also blend my colors if I want, right? As long as I'm kind of keeping those proportions in mind. I forgot to color my cactus, but I'm out of colors, right? So, but anyway, it ends up kind of working and kind of being interesting, and you can kind of say, somebody might look at a piece of art, a finished piece of art. using this approach, going like, wow, how did you choose those colors? That's kind of weird, but it kind of works. And then you could go, aha, it's because I made sure that the amount of space that each color took up was different and not, was not the same. So the obvious thing is to avoid, if you have 5 colors, ending up with 20, 20, 20, 20, 20. Same amount of space taken up by all 5. It's going to look hideous, right? But if a different amount of space is taken up by every color, you can get away with murder. All right? All right, so I think that if there's like an overall takeaway from here, I don't know. I think it's just these are some ways that we just went over to do this, to fill in the unexplored spaces, right? Of how many colors and how much contrast do they have outside of the traditional answers, which are those 5 or 6 key color schemes. And with more tools to play with, I think, at least this has been true for me, playing with new tools gives me the confidence to experiment. Because if it looks terrible, I know not to expect to be an expert in it, because I'm just experimenting with something I haven't tried before. And so it kind of releases you from the burden of that. Excuse me. I'm coming up on an hour and 10 minutes, so let me just give you one final thought. Actually, let's phrase it this way: an exercise. Let me give you an exercise, something to try with whatever kind of creativity you do, whatever kind of visual art or design you create. Choose a key color you like. I don't know, my son's favorite color is orange. So here's, for my exercise, I'll choose a slightly desaturated dark orange. Okay, choose one key color. Then develop a scheme, a harmony, a set of colors, a palette, by plotting out actually 4 or 5 different versions. Okay, so we want to see drafts. 4 or 5 drafts of color schemes. So, do like little palettes or something. And what you're going to do is decide how many colors, and then instead of saying, well, what kind of harmony am I going to use, just make sure that no 2 colors have the same purity level. No 2 colors have the same chroma or saturation or whatever you want to call it. Okay, that's the first rule. The second rule is that no 2 colors have the same hue angle difference. So like the proportion of hue thing we were talking about, the Fletcher thing. So no 2 colors have the same angle difference, right? Okay, so we're putting together Sawyer's way of thinking, right? Use different chromas. And Fletcher's thinking, use different spaces between your hues. Okay, and I'd say challenge yourself to do this with different amounts as well, like different numbers. So let's start with my orange. Actually, whoops, I want this desaturated orange. I'll do one that's only 3 colors, right? And then I'm gonna fill these all out and try different combinations where no 2 colors have the same chroma. So if you're working digitally, you can easily monitor that by changing your saturation. Make sure your saturation is different, perceivably different, and then make sure that you're not spacing things evenly, but that every hue has a different amount of space between it to the next one. And I think that's just a great way to kind of mess around and practice this, and then you have something. You didn't even need to really use a color wheel or a chart that's going to show you the harmony at all, because you're just inventing it. You're creating your own way of organizing colors. And then, sketch something out and try to make sure that each color takes up a different amount of space. And with those 3 rules of just different proportions in those 3 senses, proportion of hue, proportion of chroma, and proportion of space, making sure all those proportions are different, I think you might end up with something really cool. So that's basically, I think, where I'm going to end. I mean, there's more I could go into, but I'm over time. You've been so patient and wonderful. Let me just look through the chat here and see if there's any Q&A. that might enrich and maybe bring us to a higher level of consciousness and open our third eye and all those good things. I see Gorgeous Heterochromia asking which scarlet is cooler. Let me go back to my full camera here. Okay, so the question is, which scarlet is cooler, the ones that lean toward orange or rose? And the same question for cyan. Yeah, so scarlet to me is actually the warmest color. Scarlet I think of as a red that reflects no blue, so a purely spectral red. Cadmium scarlet is probably the best example. I think cadmium red light probably also doesn't reflect any blue. But so that scarlet color, because of the way it interacts with the visible spectrum, is the warmest color. If you add a little orange to it, technically you are sort of cooling it down. It depends how you look at it. If obviously if you're adding blue, you're cooling it down. I think that's intuitive. But if you're moving away from scarlet in any direction, you are technically cooling it because it's the hottest color. It's the warmest color. And in terms of cyan, I think it's the same thing. Cyan is the coolest color, and therefore if you move in any direction away from it, toward green, toward blue, or toward gray, you are warming it, technically. So that's actually a great question. I'm actually planning a video, a breath mint. I'm planning a video on that question. That I'm going to talk about Goethe's edge colors. If you're familiar with Goethe's color theory, he's very interested in the series of warm colors and cool colors that you see as fringes on either side of a refraction. Like if you don't focus prism all the way, if the white is still in the center, you get warm colors and cool colors on either edge, and Goethe theorized about those a lot. And I think it actually becomes a useful way to talk about warm versus cool. Other questions here. We've got Qualgara says, that answered my question more than I could have hoped for. Excellent. Cool. Vigilance says, thank you. This was really educational. I hope that there's things you can take away from this and put into practice as a creative. So that's great to hear. Rebecca Solomon says, thank you so much. Rudy Tootie says, this has been a lovely lesson. I'm inspired and gonna have my friend coming over later paint with me. Oh, that's awesome. That's so great. I can't wait to hopefully see if you want to share, maybe on Instagram or somewhere. I would love to see what you guys come up with. Quagara says, thank you, man. It's been easily the most educational and exciting color class I've sat through. Wow, that's super flattering. Please keep them coming. You truly are inspiring me for my art. Awesome to hear. Thanks so much. The Cozy Report says, thank you. Thank you for being here. Gorgeous Chromia says, thanks for the answer. Yeah, watch for that TikTok video. I'll get into Goethe's edge colors, and it's quite interesting. Vigilance says, I'm curious, have YouTube subtitles just become really, really good, or is there a human involved in the transcription? Nobody's transcribing for me, so I think it's just YouTube's gotten scary good. I mean, I try to speak clearly so that it can understand me, but I don't always succeed. I haven't looked at the captions at all, so I'm curious to see how they came out. I'll check those later. Quagara says, IDK, if I perceived some nervousness from a fellow teacher, but it was truly wonderful, and you should be proud for sharing all this. Thank you so much. That's very encouraging. Certainly a little nervous, especially when I know I overplanned, and it was gonna, come down to making choices about what to skip over or whatever. But you've all been so kind of just pleasant and lovely and encouraging. So you made it easy for me. I have a lot to take away from this experience, certainly. I do want to try to do more of these. Eventually, I think the plan is, if this works out, I have kind of a partnership in the works with an app. They wanted to sign me on as talent for their app, where they want to host this kind of thing, live streams on a mobile platform that could be educational or whatever. And I said, well, I'd love to do educational stuff, and we talked a bit over the last few months. But the app is undergoing a major overhaul, and honestly, I haven't heard from them since maybe 2 months ago. So anyway, that's part of why I wanted to do this. Is I was kind of waiting around for these guys at the startup to see, like, are they ready? Can we pilot some stuff? Can we bring people over to the platform? How do we want to do this? And they just don't have it together yet. So I said, I'll just hop on YouTube and because I want to try out some material and get the hang of this a bit. So anyway, that's some background to this whole thing. Jay Burns says, thank you, super helpful. Thank you so much. Chris Moran says, thanks for sharing. You're very generous, inspiring, so much to learn. You flatter me. Thank you so much. Breakthrough Color says, thanks, Color Nerd. Always love when anyone is debunking old school wheel stuff. Glad you could make it, Tracy. Thank you so much. Appreciate that. And yeah, I mean, let's tear it down. Let's tear down the Itten wheel to its very foundations. Alex Cuddle, Cutel, I don't know, sorry, says, I notice you use a lot of older Winton oil paints. Yeah. Have you ever seen a cadmium lemon oil paint that also says azo pigment? What do I have? It holds up very well in shades. Gee, no, I don't know. If it's an azo, it might actually be a blend between like a cadmium sulfide and nickel azomethine, which would be interesting. Actually, if it's lemon, it's probably a blend with a copper azo, because that would lean it more toward green. So you might have something like a PY129 cadmium blend. I don't know. I haven't seen that in Winton, so I can't answer that really. Bryce says, thank you so much for teaching us your ways. I'm hyped for more knowledge. Awesome. Thank you so much for coming. Gorgeous Heterochromia says, hey, can you do TikTok video about clothing color to match skin undertow? It's kind of been on my list for a while to do that. But I want to do some more research. I'm also working on a video. It might end up being a longer video, and I might put it on YouTube. But I'm working on something on seasonal color analysis, because that's very related to what you're saying. Clothing color to match skin undertone. The way that colors reflect and affect perceived hue of skin, I find it's very interesting. But I have more research to do. Let's put it that way. I'm not super confident on that yet. So yes, it's in the pipeline. Chris Moran says, masterclass. Well, very flattering. I appreciate it. Thank you all. I think I'll close up shop here. Again, this will be posted, and hopefully it's a great reference for you, or at least a different way of looking at choosing colors and working through the color space. And it will stand also as an interesting time capsule of my first attempt teaching live on YouTube. All right, well, let's do it. Let's end the stream. Thank you again. You have all been a wonderful group of students and colleagues, really, to do this with me. Take care.